Hello, this is question 2 from the 2017 MAT. There is a unique real number alpha that satisfies the equation alpha cubed plus alpha squared equals 1. You are not asked to prove this. Show that alpha lies between 0 and 1. I mean, that makes sense, doesn't it? That we're going to end up then having a number between 0 and 1 added to another number between 0 and 1 in order to make 1. But that's not conclusive. So I'll have to then, I suppose, rule out the other regions. Let's start with the easy one then. We're saying, well, if alpha was greater than or equal to 1, because we can see immediately that that's not working, because alpha cubed plus alpha squared is going to be something bigger than 1 or equal to 1 plus something greater than or equal to 1. So that's going to be greater than or equal to 2. So we can't have that. If alpha... Do I go straight in for 0 or below? I think I'm going to want to split at -1, aren't I? Because then we can look at the magnitude again. So if alpha is less than or equal to -1, then we're getting alpha cubed plus alpha squared is going to be, they're both going to have magnitude greater than or equal to 1. But the cubed one's going to be negative and the squared one's going to be positive. So we're going to have something negative and of greater or equal magnitude, in the cubed one. So that's going to have to be less than or equal to 0. So we can't have that. And then we got if then alpha is between -1 and 0, then what are we going to get? We're going to get a negative number between 0 and 1 plus a positive number between 0 and 1. So that means we have to be between 0 and 1, don't we, on that? So alpha cubed plus alpha squared. Well, it's certainly less than 1, and it will be, I mean, it's got to be greater than 0 because the squared term would have dropped down to 0 less. So none of those work. So it must be then what they want. Okay, a little fiddly, but it was okay. Right, part 2, show that alpha to the power 4 is equal to -1 plus alpha squared. Right, okay. How are we going to get an alpha? Well, alpha 4, I suppose the obvious thing to do is multiply this thing by alpha, I suppose. So we get alpha to the power 4 plus alpha cubed is equal to alpha. And we don't have an alpha cubed in this. So let's replace it then with a 1 minus alpha squared. Oh yeah, we got everything we need now, haven't we? So that means that alpha to the power 4 will be -1 plus alpha squared. Right, that dropped out pretty swiftly. Part 3. 4 functions of alpha are given in A to D below. In a similar manner to part 2, each is equal to a quadratic expression in alpha where A, B, C are integers. They're the integer coefficients. So in part 2, we found that A is -1. Yeah, B is 1, C is 1. You may assume in each case that the quadratic expression is unique. In each case, find the quadratic expression. Right, so we're starting with 1 over alpha. Right, well, we can get a 1 over alpha by dividing all this by alpha. So let's do alpha squared plus alpha equals, well, that's just it, isn't it? So we've got that A is equal to 0, B is equal to 1, C is equal to 1. No, they didn't want much in part A, but I suppose they're just getting this into the swing of things of what it is we're actually trying to do. So that was A. So for B, the infinite sum of that, so we're multiplying by minus alpha each time, and magnitude of alpha is less than 1, so this will give us sum to infinity being A, which is 1 over 1 minus R, so that'd be 1 plus alpha. Right, that's fiddly. So how do we turn that into a quadratic off of this? Well, I suppose previous part doesn't help. That doesn't help. All we've really got to go back to is this, I suppose, haven't we? We haven't got anything else that we can do, and the only thing we can sub for is 1. So, well, let's do that then. So alpha cubed plus alpha squared over 1 plus alpha. Okay, yeah, so they're going to cancel. We've got a 1 plus alpha top and bottom, so that's just going to be alpha squared. So we've got that A is 0, We got B is 0, and we got C is 1. Right, that was good. C, what we got now? 1 over 1 minus alpha. Well, it looks very similar to the previous part. So try it again. So alpha cubed plus alpha squared over 1 minus alpha. So, well, divide it through, I suppose, and see what happens. So we've got minus alpha plus 1 going into alpha cubed plus alpha squared. Right, so let's do the long division. So we've got to multiply by minus alpha squared. That gets us alpha cubed minus alpha squared. So we subtract those to get 2 alpha squared, which means we need to multiply by minus 2 alpha, which gets us the 2 alpha squared minus 2 alpha. So we subtract that to get 2 alpha, which means we have to multiply by minus 2. So that gets us minus 2 alpha, well, plus 2 alpha, I should say. 2 alpha and then minus 2. Subtract that to get our remainder of 2. Right, so that was a fiddly effort. So we've got that 1 over 1 minus alpha is minus alpha squared minus 2 alpha minus 2 plus 2 over 1 minus alpha, which is the thing on the left-hand side. So we just subtract everything here. We subtract all of these 3 terms from both sides and that from both sides. Gives us alpha squared plus 2 alpha plus 2 is 1 minus alpha and minus 1. So we've now got that A is 2, B is 2, C is 1. Right, this is going swimmingly. So we've done that one, we've done that one. The infinite product. Right, infinite product. 1 plus alpha, 1 plus alpha squared, 1 plus alpha to 4. Right, we don't really know. Where do we go with this? Where do we go with this? Well, it's going to be a right mess. Maybe expand it out and see what it looks like as we're building it up, because I can't see how we can sub anything in. I mean, 1 plus alphas, we're just going to be getting alpha cube things appearing in here immediately, and we can't deal with these high powers of alpha. So yeah, okay, so if we just did, so we're going 1 plus alpha is our first bracket, then we do the next one, which will be expanding out to get 1 plus alpha squared plus alpha cubed. Okay, that seems promising. Then we need to multiply that by 1 plus alpha to the 4. That's what's coming up next, isn't it? So we're going to get all of that lot, 1 plus alpha squared plus alpha cubed. And then all of this again times alpha to the 4. So plus alpha to the 4 plus alpha to the 5 plus alpha to 6. Okay, alpha to 7. And then we're going to 8. So again, okay, we're going to do the same thing. So we're getting an infinite sequence multiplying by alpha. So it's a bit like the second one, but now we've got alpha. So sum to infinity is going to be 1 over 1 minus alpha. Yeah, we've just done that. So that is alpha squared plus 2 alpha plus 2. So exactly the same as we had before. It's the same as part 3. Okay, that flew through that question, really. So yeah, continuing on from the slightly generous multiple choice section on 2017 paper, we've got much the same in question 2.